Welcome to AD Mathematics, and in this video we are going to look at reduction of cells in its basic form. Notice that in the previous video we did the definition of cells, where we said a cell is an irrational number which remains in its radical form. Now we also learned that sometimes a cell may or may not be in its basic form, and it is always desirable that we achieve or we transform that set to its basic form. We said, when do we say a set has been reduced to its basic form? Do you remember? Okay, very good. We said a set is in its basic form if it contains, in fact, I didn't specify. I said a set is written in the form A over B, right? So this particular set is in its basic form if B, not A, sorry, if B, so the focus is on B. So a set in the form A with B is in its basic form if B does not have any perfect square factor. So B doesn't have any perfect square factor. If this condition is met, we say the set is in its basic form. So now let's look at let's take square root of 24 as we used in the previous video. For you to know if this set is in its basic form, try to list down the factors. I know this is quite a long process, but remember we are learning from scratch, and with time we may be able to develop our speed. So don't worry, let's start from scratch. So when you have, let's say, square root of 24, do you know what you do? Try to list down the factors of 24. What are they? 1, 2, 3, 4, 6, 12, and 24. Now you ask yourself, among the factors, are there perfect factors? Yes. Are there perfect numbers? Yes. 4 is a perfect number, or it's a perfect square, right? Hence, square root of 24 is not in its basic form. Let me give you example 2. Example 2 is square root of 30 in its basic form. I'm giving you some seconds to think about it. You can pause the video to try your hands. Oh yes, I believe you had it right. So how do I know this is in its basic form? I will list down the factors of 30, which are 1, 2, 3, 5, 6, 15, and 30. So I ask myself, among these factors, do we have a perfect square? And the answer is no. Hence, we can say root of 30 is in its basic form, or this particular set is in its basic form. Last example, square root of 12. Is this in its basic form? Okay, try your hands. You can pause the video to try. For the sake of time, I'm doing it. So you list down the factors of 12. We have 1, 2, 3, 4, 6, and then 12. Ask yourself, is there any number which is a perfect square? Remember, in the first video we talked about perfect square. If you want to form a perfect square, write the counting numbers 1, 2, 3, 4, and so on and so forth. Try to square them. So you take 1, you square, you get 1, meaning 1 is a perfect square. You take 2, you square, you get 4, meaning 4 is a perfect square. You take 3, you square, you get 9, meaning 9 is a perfect square. You take 4, you square, you get 16, meaning 16 is a perfect square. So that's how we form a perfect square. Remember, for you to find the square root of a number and get a whole number, square root basically means what number multiplies itself. So when you say square root of 16, what number multiplies itself to give 16? And the answer is 4. Okay, that was just by the way. So now we could see that 4 is a perfect square because square root of 4 is equal to 2, which is a whole number. Okay, I believe we are learning now. Now, let me clean here. Now that we've been able to identify whether a number is in its basic form or not, there is the last thing that we have to know. Reducing that set. Remember, I told you a set can only be reduced when it is not in its basic form. Once a set is once a set has been reduced, we say it is in its basic form, right? So let's take our example that we use, square root of 24. Now we saw that 24 has factors 1, 2, 4, 6, 12, 24, right? And we saw that 4 is a perfect square, hence root of 24 is not a perfect square. So now the question is, how do we reduce this if it is not in the perfect square form? So it is simple for you to do this. It's very, very simple. Take that perfect square. Take that perfect square, which is a factor of the set or the number inside the square root. So here, what is it? It's 4, right? Then you ask yourself, 4 times which number will give me that 24? So if you want to find, is 4x is equal to 24, meaning 4 times a number is equal to 24. Basic algebra, make s the subject. X is equal to 24 over 4. We get what? 6. 4, 6, 24. Or 4 goes into self 1. It goes into 24, 6. So now we say 4 times 6 is what? Is equal to 24. Now notice that in the question we have square root of 24, not just 24. So we find square root of both sides. So we bring our square root. Now we've been able to transform square root of 24 to the product of two numbers, which is 4 and 6. Please, are you good to go? Yes, I believe you understand. So let's move on. Now, so 24 has been transformed into 4 and 6. 4 times 6, 24. Now, there is this property that we will prove, but for now, let's learn it. When you have the square root of a times b, let's say you have square root of a times b, this expression is the same as square root of a times square root of b. For example, when you have square root of 3 times 10, you can write it as square root of 3 times square root of 10, and it will give you the same answer. Okay, let's try another example. Let's say you have square root of 7 times 15. This is the same as square root of 15 times square root of 7. Yes, I believe we get the concept now. So now let's use that property, though we will prove it in the next video or in the next 2 videos. Don't worry, just follow along, you will understand it. So now here we say we have square root of 4 times square root of 6 is equal to square root of 24, right? Now what is the square root of 4? I told you the square root of a perfect number is what? Or a perfect square is what? Is a whole number. So the square root of 4 will give us 2. So we have 2 times root of 6, right? In mathematics, when you have a times b, what do you get? We get ab. So the same way, 2 times root of 6 will give you 2 root 6. 2 root 6 means 2 times root of 6. Okay, so now notice something. The square root of 24 has been transformed or reduced to 2 root 6. We say 2 root 6 is the basic form of square root of 24. Let's take another example. The last example, example 2. Let's take square root of 45. Okay, so I told you, first of all, before you can reduce this, you have to check whether it is in its basic form or not. So we list down the factors of 45. We have 1, 5, 9, and 45. Among the factors here, do we have a perfect square? The answer is yes, we have. So now we choose that one, which is the 9, right? So we say square root of 45 is the same as square root of 9 times. Then we ask ourselves, 9 times which number will give us 45? The answer is 5. Remember, we want to make the left hand side equal to the right hand side, right? And now, per the property we just learned, we saw that square root of 9 times 5 can also be written as square root of 9 times square root of 5. And now we say square root of 45 is equal to, what is square root of 9? 3. I mean the positive square root, times root of 5, right? So we have square root of 45 is equal to, I told you 3 times root of 5 is the same as a times b, ab. So you just write 3 root 5. Okay, so I want to keep this video short. Don't forget to like, share, comment, and subscribe to AD Mathematics. See you in the next video. Bye bye.